Hey guys, welcome to my YouTube channel, and today I'm recording Cambridge O Level 5070 Paper 1. This is Variant 2. This is October-November 2020. This paper is of 1 hour. I've already solved other papers of multiple choice questions from Cambridge O Level Variant 2. This is October-November 2020. You can check out my May June 2021. The playlist is in the description below. So without any further ado, let's get started. There are total 40 MCQs in this paper, and I have started recording this. So this is part 1, and then I'll be uploading more parts really soon. So make sure to subscribe and don't forget to ring the bell icon to be updated as soon as I post a video. So let's start with MCQ number 1. During a titration experiment, an acid is transferred into a burette. The diagram shows part of burette at the start of the titration and at the end point. What is the volume of acid used during the titration? Okay, so here titration is taking place, and we need to calculate that how much acid has been used up during the titration. So for this you can subtract the volumes, and then you will get to know that how much acid there's change in acid. So how much acid has been added into the burette, you can easily get to know. So since it's 27.3 minus 22.4, okay, so if you're going to subtract it, so your answer is going to come obviously 4.9 centimeter cube. So for this the answer is 4.9 centimeter cube. Moving on to MCQ number 2. When calcium carbonate is added to dilute hydrochloric acid, carbon dioxide gas is released. 3 sets of experiments are shown. This is cotton wool, this is mass balance, CaCO3 plus HCl. Okay, so which sets of apparatus are suitable together with a stopwatch for following the rate of the reaction? If we look over here, we have 3 different kinds of setup with us, and we are supposed to understand that which apparatus is better together with a stopwatch for finding the rate of this reaction. So over here, if we look over here, so mass balance can help us. So this one will definitely help us, this set of experiments. This is correct. And let's see if this one can, right, we have gas syringe over here, so it can definitely help us, since we can measure the gas that is being collected, and then from stopwatch we can check the time that how much gas has been collected and find the rate of reaction. If we look over here in measuring cylinder, we have crystal funnel. No, this is not a very helpful idea for a very helpful setup for the rate of reaction, since in these two we can find the time through using a stopwatch. So yes, we can use these two, because here we will find the difference in mass, and here we will find the difference in gas through gas syringe measurements. So moving on to MCQ number 3. Chromatography can be used to separate and identify dyes present in a mixture. Which statement is correct? So for this so chromatography is a kind of a process in which we use a filter paper, and on the filter paper we draw a line, particularly with pencil, since it does not have a combination of dyes together. So that's why we use a pencil, so that the result, because if we use any other kind of ink, for example, it will be a combination of dyes, or it will be a dye, so it was also going to show its result. Hence it is going to confuse us with our main, what dye we are supposed to find the RF value of. It is going to be really difficult to find that out. So that is why we use a pencil, and then we put the dye on it, and in case the dye does not have a color, we use a locating agent, mainly ninhydrin. So this is basically an overview of chromatography, the process. And for finding the RF value, what do? Is we put different distances of, so we consider solvent, ratio of solvent, and we consider the ratio of the distance of the ink spread out and the solvent height. So let's look into it. A dye with an RF value of 1.2 can be present in a mixture. So well, no, this is not the right answer, of course, because a dye with RF value of 1.2 cannot be done, since solvent is always going to be on a greater height, so we cannot have an RF value of 1.2. And then a dye could have a different RF value if a different solvent was used. Yes, if we have a different solvent used, of course the RF value will also be changed. Alright, so option C, all blue dyes have the same RF value. Not importantly, chromatography can be used for colored substances such as dyes. Can only be used, no, it can be used for other chemicals too. So no, this is also not the right answer. The right answer for this is B. So we have so many B options here if we look at it, right? Till now all of them were B. Okay, so moving on to MCQ number 4. Petroleum crude oil is separated into useful fractions by fractional distillation. The positions at which fractions X and Y are collected from the fractional column are shown. Fractionating column, okay, are shown. So which statement is correct? We have 3 levels over here, X, Y, and we have 2 levels over here, X and Y. And we're supposed to find the right statement according to the properties or features of any fractional distillation, looking at the fractionating column side. So the temperature increases up the column. Well, for this, no, the temperature does not increase up the column. X condenses at a lower temperature than Y. Yes, it condenses at a lower temperature, hence it's on a greater height. So that is why this is the right answer. But let's take a look at the other parts too, at the other options too. X has a higher boiling point than Y. No, it has a lower boiling point than Y, since it has boiled before, like it has turned into gas probably, or it has, reached to a greater, the particles are way further away in X than in Y, hence its boiling point is going to be lower than Y. And X has a longer chain of molecules than Y? Absolutely not, because which has longer chain is going to be at the bottom, or is going to, have greater boiling points. That is why X has a shorter chain than Y. So moving on to MCQ number 5, aqueous zinc chloride is tested with various reagents. Which observation is correct? Aqueous ammonia gives a white precipitate which is soluble in excess reagent. Yes, okay, this is correct. We found already the right answer, because zinc chloride, Zn2 plus, Zn2 plus, right? Zn2 plus zinc chloride. If we look at it, so zinc not being in transition metal can give us white precipitate. Copper turnings give a precipitate of zinc, no. Acidified aqueous silver nitrate gives a yellow precipitate, not at all. And barium nitrate gives white precipitate, again no, this is not the right answer, so its answer is A. Aqueous ammonia gives white precipitate which is soluble in excess reagent. Moving on to MCQ number 6, when aqueous sodium hydroxide is added to a solution, a white precipitate forms which dissolves when excess sodium hydroxide is added. Which ion could be present in the solution? Okay, so if we look over here, most probably, if we look, okay, so for this you need to go through the salts chapter very thoroughly. Always remember that if you are giving this examination, you should give enough time to learning the properties and learning about the salts, mainly that what gives which color precipitate, what chemical results in what kind of an output. It's really important to go through this. Without it, you will not be able to solve MCQs and you will lose a great amount of marks. Alright, so since you only have 40 MCQs, I think around 4 to 5 MCQs do come from this part of the chapter. More than that at times. Sometimes it's like at least you'll have 3 MCQs from it related to it. So make sure to properly go through it and be able to do it, because it doesn't really have a logic, but it's more about experimenting it and it's more about observation. So make sure in lab you perform all these experiments with great focus, so you're able to solve these kind of questions. So for this the answer is aluminium. It's not calcium, not copper, neither is sodium. So moving on to MCQ number 7. A sample of gas occupies a volume of 2 dm cube at room temperature and pressure. Which changes in the conditions would both decrease the volume occupied by the gas? Okay, so here if you talk about volume, over here if we see, let's highlight it. If here we are decreasing the volume, we want the volume should be decreased. Always remember that volume is directly proportional to temperature and inversely proportional to pressure. Okay, again, I'm repeating again. temperature and volume are directly proportional, and pressure and volume are inversely proportional. So if we look at direct proportional part, that means temperature should be decreased 2 so that the volume can be decreased, and pressure must be increased so then the volume will decrease, since they have an inverse proportion. So for this the answer will be decrease and increase, which is option C. Right, so this is how it is going to be done. There are so many factors why it happens, mainly because, okay, if we look at volume, if we increase the temperature, for example, if we look at the pressure and temperature, if we have 1 atmosphere pressure and we have 100 degrees Celsius of water, so it is going to be boiling at this kind of a condition. However, if we decrease the pressure, again I'm talking about decreasing pressure, if we decrease the pressure, so the temperature will also decrease. That means it will boil at a much lower, at a much lower temperature. So if we go in high areas, mountainous areas, so over there pressure is really low, so water can be boiled at a lower temperature. So I hope you get the point, right? MCQ number 8, an anion, it's not anion, it's anion, contains 20 electrons and has a charge of 3 plus. From which element was the ion formed? Again, if you look at it, its answer will be, okay, so we have calcium, that is aluminium 3 plus. However, it does not contain 20 electrons, alright? So this cannot be the right answer. Then if you look calcium Ca2 plus, it's not going to be the right answer. Iron can be Fe3 plus, Fe2 plus, however, it's again electrons differ. However, if you look at vanadium, so yes, its answer can be vanadium, of course. If you want, you can check this through periodic table if you don't remember exact charges and all. This is the periodic table given to us. So if we look over here in the periodic table, we had aluminium. So if it is in this 3 plus, right? However, it is in third group. However, although its valence shell are 3, however the electrons are 27, so it's not the right answer. However, if you look at vanadium, that is this. So sorry, here 13. It's 13. Sorry, not 27. I saw it wrong. 13 are the electrons. All right. So it's not going to be this, because if we are going to subtract 3, if it makes a charge of 3 plus, so it's going to be 10, not 20, so it cannot be the right answer. But if you look at vanadium has electrons 23, alright, and if we have this 3 plus charge on it, that means if it loses 3 electrons, so its answer is going to be 20 electrons are left. So that is why vanadium is the right answer. Moving on to our other MCQ. Where did it go? Okay, here it is. So for this the answer is vanadium. Which statement is correct? Diamond conducts electricity while graphite does not. It's absolutely wrong, because graphite is the only carbon that can conduct electricity, and so for this A is not the right answer at all. Graphite has delocalized ions between its layers. No, it does not have delocalized ions. In diamond, each carbon atom is joined to 3 other carbon. No, it's again not the right answer. Moving on to part D, the layer structure of graphite makes it slippery. Yes. Okay, so graphite is basically, we have carbons over carbon layer over carbon layer, and then the other carbon layer on it. So it's kind of really formed in layers. That means it makes it slippery. It does not have a very rocky kind of a structure. It does not have a very how can I put it? It can be said as if disarranged. It is not very unarranged. It's really layer wise, very properly over each other. So that is why it makes it slippery. Moving on to MCQ number 10. Which material has the highest melting point? Highest melting point, if you look at it, ammonia does not have a very high melting point. Methane again does not have a high melting point. Sodium chloride does, because sodium chloride is an ionic compound. It has a really high melting point, since they have really strong attraction forces between them, and overcoming them is a big deal. So it's not it of course has a higher melting point. Again, water is not having a high melting point because you see these are already in liquid and these are in gaseous form normally, so its melting point is not high at all. At room temperature it's really low. Alright, so this is how you're supposed to solve this paper. I hope you found it helpful. I will be posting further parts really soon, so make sure to subscribe and ring the bell icon. And thank you so much for watching, and best of luck for your exams.